Hello, everyone. It looks like I have the top of the hour on my clock, so let's get started so that we have enough time to get through everything today. I hope you're all having a good day so far, staying warm if you are in one of these very cold environments like I am today. So today we are going to talk about GeoWeb system for earth retention, including both vegetated and non-vegetated options. So I am your host, Sam Justice, and I'm a licensed professional engineer in a couple different states, and I do have degrees in civil and geotechnical engineering. I'm one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. And through an extensive national and international distribution network, we offer both technical and site support, as well as free project evaluations from our in-house technical engineering team, like myself. So we are going to be covering both steep slopes and retaining walls today. The GeoWeb system works for both types of applications, and the big difference between the two is going to be the batter of the wall, or that slope face angle. And we are going to get into details about each one, so don't worry about the specifics at this exact moment. So we are going to cover the causes for that type of superficial erosion, how they can contribute to the failure, how the GeoWeb 3D geocellular system can work to protect against those types of erosive forces, and how to apply the system in different types of conditions. And then in steeper areas, we are going to look at the different types of retaining wall systems that we offer, their attributes, their features, all that kind of good stuff. So you can see our learning objectives on here. Hopefully we get through everything and it all makes sense. But definitely feel free to type in questions in your questions tab, and there will be a Q&A session at the end. All right. Presto Geosystems worked with the U.S. Army Corps of Engineers to develop the GeoCell technology in the late 1970s, and we continue to be a leader in innovation ever since. We do offer more than just a product. We work with our customers from the initial concept phase through construction to support a successful project. We have a worldwide distribution network experienced not only in the GeoCell technology, but other geosynthetics as well. Our assistance does not stop when the product leaves our door. We're here to help through all of the different stages. We do operate in 4 main product areas I mentioned, one being with our GeoWeb geocells. Those can be with load support, slope and channel protection, and constructing green retaining walls. That should ring a bell of what we're covering today. Presto Geosystems also offers porous pavements, which we have both vegetated and stone solutions, and lightweight reusable construction mats. Not going to focus on those today, but if you do have questions, feel free to reach out to me once we're done here. Like I said, today we are going to focus on using GeoWeb geocells for steep slopes and retaining wall applications. So we are going to start out with a description of what the GeoWeb 3D soil stabilization system is, what geocells are, if you are not familiar with this type of product. They have been around, like I said, since about the 1970s, but some people haven't heard of them. They are still relatively new in some locations and for some applications, and I just want to make sure we're all starting from the same page. So the GeoWeb system is our version of the GeoCell technology, and it consists of 2 main attributes. The first is going to be the cell, or the container size. So the cells do come in 3 diameters, basically a small, medium, and large opening, and the number of different depths. And GeoWeb walls in particular are typically made with our 30V cell size. That's going to be the medium size opening, but there are other options available. And then the standard depth for a GeoWeb wall is either going to be 6 or 8 inches. Regular GeoWeb panels intended for other application types do come in other depths, 3, 4, and 12 inches. Specifically. And so the dimensions and the cell depth is going to depend on your project specific details and your site requirements. And so we can help you determine which one is going to be the most appropriate for a specific job. There is no one right size fits all. And again, there are a number of different cell lengths to help you determine what is going to be most appropriate for your job. So there's a lot of different factors. It is not just a single product. It does have a number of different permutations, let's say, but we can help you determine which one is going to be the most appropriate. Something I do want to point out about geocells specifically is going to be the ultrasonically welded seam. And that's where all of the connecting points are. And that's really important to the function of a geocell. The stronger that seam strength, the better the performance the geocell is going to have, period. A strong seam allows for a better overall lifetime performance and steeper and taller slopes. The GeoWeb system is produced using a high-quality virgin high-density polyethylene HDPE resin for consistently strong welds at every seam, while also maintaining semi-rigid ductile properties, high stress crack resistance, overall toughness, and long-term durability. The GeoWeb geocells do not use any fillers or exotic polymer alloy blends, which can ultimately reduce things like your weld strength. And those sorts of things, those alloys or polymers, are sometimes offered in competing products in the name of increasing your cell wall stiffness. So to avoid weld failures and the damaging effects of differential settlement, you really want to focus on uniformity in performance across all elements of a geocell system rather than focusing on a single parameter such as cell wall stiffness alone. The second attribute that I want to point out in a GeoWeb system or any geocell system is going to be the infill material, and specifically for retaining walls, this is what's going to be put in that front cell. It's going to be what you would see at the face of the wall. So there are three main infill types that can be used with the GeoWeb system, and that includes topsoil for vegetation for a nice living green wall. Then you can also hard armor your walls using a crushed aggregate or granular material, or even concrete, depending on the type of protection that's needed. So you can do one type, two types, three types. You can mix them all together depending on what you need for your specific site and what type of protection you're looking for. And I do want to mention that the GeoWeb system and all of our accessories are 100% made in the USA under strict quality assurance and environmental control processes, and they are sure to comply with any requirements for the Build America, Buy America, and the Infrastructure Investments and Jobs Act. So if you are getting federal funding for any of your projects, if you have any sort of requirement saying these need to be a made in the USA or a American-made product, all of our systems and all of our accessories do fall under those types of categories. We can provide sort of documentation for any of that you might need. So just something to keep in mind. One last thing that I do want to point out is going to be one of our accessories. It's something that is a patented system, and it is unique to the GeoWeb geocell rather than any of the competitors that might be out there on the market. And that is the ATTRA wall key. And it is the major component for a completely integrated earth retention system. So the ATTRA wall key is a device used to connect adjacent GeoWeb retaining wall sections through the material eye slots. So these are perforations in the panels intended to help you connect the different panels together. So the ATTRA wall key includes an integrated washer at the base of the handle for complete coverage of that opening, plus frictional barbs for an improved interlock with the GeoWeb sections, and finally an ergonomic handle that is S-shaped contouring for the ease of installation. And so it is formulated to withstand both weathering and ultraviolet radiation. So the ATTRA wall keys are not going to corrode or photodegrade even when exposed to harsh environments. And so this is compared to something like using metal staples or your standard plastic zip ties that you might get at any sort of hardware store. These ATTRA wall keys are designed specifically for these types of projects and to be put in even the harshest environmental conditions. They require no specific or specialized tools. They can be completed by a single installer. You don't need to have, you know, a stapler or anything like that. This is just a turn and go system. So it is a great benefit to using the GeoWeb system. And I do want to sort of highlight what a specification summary might look like for a geocell system. And so in order for a geocell system to perform uniformly, it is critical that both the factory welded junctions, those seams that I talked about, plus the field joint junctions, that's the actual wall key that I just mentioned, are all able to perform at a level that's commensurate with that of the cell walls. So those are the three primary elements of a geocell system: the cell walls, the internal junctions, and the connectors that you should all see on a specification summary. And again, it is much more important to have a uniform characteristic across all of those systems rather than an emphasis and a focus on a single characteristic, such as environmental stress crack resistance. If you only focus on that, you are doing that to the detriment of everything else that makes a geocell system work. So it is just really important to make sure you have that uniformity in performance. That's kind of the key word that I want you to take away from all of this. I'm just going to keep mentioning that word, uniformity. But the GeoWeb system is, as I mentioned, manufactured with that high density polyethylene, no fillers, no polymer alloys, nothing unstable about it. It is going to retain its durability, with lab testing indicating greater than 150 years. We haven't reached that mark yet. We've only been working since the 1970s, but we are well on our way. And so that is even at full exposure to the elements. So we do stand behind our numbers so that you can deliver in a solution as you build with materials that you can trust. So just something to keep in mind, especially if your contractors do come back with sort of an or equals clause, trying to come in and see if they can get something else put in. Make sure that that type of material is going to meet the standards that it needs to. All right, so with that little PSA out of the way, let's have a quick discussion about the fundamentals of those types of retaining walls. So the GeoWeb retaining walls are in many ways similar to other types of mechanically stabilized earth structures, so MSE wall systems, but they do have a couple key advantages that a geocell system might have over, say, a gabion basket wall. And I do want to sort of highlight what our definition is between a steep slope versus a retaining wall. I've mentioned it a couple times. I'm going to keep saying those two different terms as we move forward. Again, just want to make sure that we are all on the same page here. So for us, for geocell systems, for how we move forward with this sort of thing, retaining walls are defined as structures with a batter of less than 20 degrees, so very steep. And steep slopes are areas where that slope angle is between 45 and 60 degrees, excuse me, 70 degrees. I can do math. So 45 and 70 degrees. So again, up to that 20-degree batter. However, we do build GeoWeb retaining walls shallower than that 20-degree batter that I just mentioned. We've gone as low as a 45 degrees, so a 1-to-1. You can do that. So it's a bit of a loose definition, but that's sort of that line of where we draw the difference. Probably the biggest difference between a steep slope and a retaining wall is that the walls are built to provide a globally stable structure with internal reinforcement, whereas steep slopes are intended to help mitigate potential surface problems in an already stable area. And that's kind of going to be the key difference is your slope already stable and maybe it's just seeing a bit of superficial erosion or sloughing, or are there actual deep-seated erosion concerns that you are concerned with? Maybe there's a circular failure that's happening leading to mass movement. One of those is going to need internal reinforcement, one of them's not. Internal reinforcement is going to lead you to retaining wall. Superficial issues are going to lead you to a steep slope type of protection. And again, we can help you determine which one is going to be appropriate for your site. So if you're not sure, feel free to reach out to us. More than happy to discuss the differences between the two, help you determine which one is going to be the most appropriate. So for steep slopes, it is an attractive earth retention solution for a number of reasons. And one of the biggest benefits is the ability to build a solution that fits well with your surroundings and doesn't look out of place as something that, you know, if you just have a really tall wall structure, it can sometimes look out of place, especially if it's, you know, near or on an otherwise existing slope, and suddenly you have a vertical wall structure that looks really obvious. It looks really built up. It could solve the issue, and that's definitely an important aspect of what we're doing, but sometimes you want it to look a little more natural. You want to blend into the surroundings a little bit more. And so a steep slope solution is a great way to do that. And so you can have room for that set type of application without it looking completely man-made and built up. And so the GeoWeb system is a really versatile option for that type of thing. And so that's what we're seeing here. So that previous photo was where the GeoWeb system was being installed and being placed in at a steep slope. And then here it is as it's getting filled in with grass and trees and looking nice, except for a little area that wasn't stabilized. You can see that it's starting to fail again. So that's what we're sort of talking about here. You can see that it looks much more natural. It looks kind of like everything else around it. You don't necessarily drive this road and go, oh man, they built up this big wall here, but it is protected. And you can see the areas where there wasn't that GeoWeb system put in place, and it's already starting to fail. And so maybe they're going to come back. And in this case, they did come back and put in more GeoWeb system to try and mitigate further failures on this road. So it's just something to keep in mind. You can have this really nice sort of green wall face, allow that vegetation to grow through, even larger vegetation. You can see some trees going in, larger shrubs, that sort of thing. So that is probably one of the greatest benefits to using it as a steep slope aspect. So if you do have the ability to have a slightly shallower grade, if you're not going for as steep as possible, this is a great way to make it look very natural, very in place. And that can be a really nice, attractive benefit for some people. All right. The decision as to whether or not to use that wall or that steep slope, as I said, is going to depend on your site topography, the end use of it, how, are there going to be lots of vehicles driving over the top of it, that sort of thing. And then also the soil properties that you have. If you have really good soil in place that can handle a steep slope on its own, that doesn't need a lot of internal reinforcement, that can help determine the final product, that sort of thing. So wall structures are going to be more noticeable. That's just because that's how they are. There's a steep wall structure. People are gonna notice that. It doesn't look natural, like something that would naturally fall through the earth. This is something that obviously has been man-made. Doesn't mean that walls can't look nice or blend well with their surroundings. That's one of the really good benefits of using it as a green wall structure. Still allow that vegetation to grow through. Let it look nice. Let it, look as blended in as a steep retaining wall can. And a majority of GeoWeb walls are vegetated for a variety of reasons, but aesthetics are probably a big one. Stormwater reduction is a big deal, allowing for that water to infiltrate through. Vegetation can capture stormwater runoff, even from hard surface pavements, so it can be really nice to sort of integrate that quickly into the groundwater system. So if you have that ability to do vegetation, it's a really great option. It's probably one of our most common applications. So let's talk about retaining walls in a little bit more detail. You can have either a gravity style retaining wall or a reinforced retaining wall. Gravity walls don't require any sort of geosynthetic reinforcement behind the GeoWeb wall face. 8 feet is typically the generally accepted maximum height. We do follow the Federal Highway Administration's standards for building MSE retaining walls, FHWA standards. So if you're familiar with those, you will understand the type of methodology that we use for the GeoWeb system. If not, don't worry about it. More than happy to discuss it if you do have questions or if regulators have questions, but that's the methodology that we follow. So that's where that 8 feet usually comes in for gravity style walls. So if you do have a fascia wall, so if you are going up against a weathered rock face or bedrock, something like that, you could have just a fascia where you're basically just putting the GeoWeb panels in front of this rock face so that you can get that green retaining wall, that green face, because bedrock typically does not grow vegetation very well. But so you're just sort of building up a little bit of a face in front of it. You can also have a gravity style wall that is steeper or taller, than 8 feet. That's again, really project dependent, but more than happy to talk to you about it. So gravity walls, like I said, don't require any sort of geosynthetic reinforcement, which are typically something like a geogrid tieback, rock anchors, something like that, that help hold everything in place. And so this is a photo of a gravity wall, as you can probably imagine. In this case, it was about a 6-foot tall wall, but it did have a little bit of a surcharge. You can see they were actually putting construction equipment behind it there. And so if you are having a couple different requirements for your retaining wall, if it's got vehicle surcharges on the top, if you've got water flow in front of it, something like that, gravity style walls might not be the best option. They're a bit finicky, especially during the installation period. Reinforced walls are usually a little bit stronger, but gravity walls definitely possible. Don't think that they aren't possible or that you have to have reinforcement at all times. Basically where I'm going with that. But the majority of GeoWeb walls are reinforced using some type of geosynthetic, typically uniaxial geogrids. So the general principles of reinforcement of a GeoWeb wall are going to be the same as other types of geogrid reinforced MSE walls. Masonry block walls come to mind as something that you would typically see with geogrid reinforcement. So these types of walls can require a lot of excavation in order to place the geogrids, but they're not limited in height. So if you do have a very tall wall that you need to build, this is going to be the way to go. And so the majority of reinforced walls do use basically the smallest size of GeoWeb that we offer. And that is because most of the reinforcement is coming from the geogrid or geosynthetic tiebacks. And so the GeoWeb walls are holding those tiebacks in place and allowing for that installation to happen. So you can have typically a 6 or an 8-inch deep panel, and that allows you to have a good separation of your geogrids so that you can have that reinforcement without, overdoing it. You don't want to have a reinforcement layer every 6 inches. That's excessive. But by having a standard GeoWeb separation between your geogrids, typically about 2 feet, 2 to 3 feet is again that FHWA standard, then you can have a good strong wall with the required reinforcement. And so while reinforced walls are not limited in height, it still may be beneficial to use multiple tiers of shorter height walls. And that's because the length of the reinforcement might become too large with a single tier. So the ratio of wall height to reinforcement length is 70%. So if you had a 20-foot high wall, you need 14 feet of geogrid reinforcement behind it. 40-foot high wall needs 28 feet of reinforcement. You get the idea. So if you do have an incredibly high wall, you would need a lot of excavation to put that geogrid reinforcement in place. So if you do multiple tiers of shorter height walls, you can have shorter reinforcement lengths, still achieve your total height that you need for the wall, your total overall required height, without having to do excessive amounts of excavation. So something to keep in mind if you've got that sort of flexibility on your project site. So in the geocell world, you will come across the terminology of vegetated, non-vegetated, and stepped walls or non-stepped walls. So for GeoWeb walls, non-vegetated is going to be when you have stone or granular material as your infill, like you see in this picture, or if you were to do concrete, obviously that's also non-vegetated, or it means you've filled in with topsoil, you're allowing that vegetation to grow, and you're going to get a green wall face. And then stepped is whether or not it is in tiers, like I just mentioned, and like you see in this photo, or if it is all a single face from top to toe. So just something that you might see as you come across these types of projects, or as you're talking about them, and they just mean kind of what you think. They're not that complicated. I just want to point out that those are some terms that you might see. Let's see some other questions. So this is with that vegetated face. Like I said, the majority of GeoWeb walls are done with a topsoil infill for that vegetation growth. And you do just want to put in topsoil, something that you know is going to grow vegetation in your area. It doesn't need to be any sort of specialized blend at least from our end. Your landscape architects might have opinions about what the best soil type is, but in our world, in our sense, it's really just whatever is going to help grow vegetation in your area. And that's the same with the type of vegetation. Grasses, flowering vegetation, ivies, that sort of thing are great options for trying to grow these this type of vegetated wall. You're not going to be able to put in large trees. I think everybody can sort of see how putting in an oak tree in the middle of this would be complicated and probably not super helpful. So keep that in mind when you're thinking about your vegetation, but the specific type of vegetation is not important. The specific type of topsoil is not important. It's more about what's going to grow in your area, because if you put topsoil in and then you're in northern Canada and you try and put Kentucky bluegrass in, that's not gonna work necessarily. So go with what's local to your climate, what you know is gonna grow in your area, what's gonna look good, what's gonna blend well, that sort of thing. All right, so it's not hard to see why you might want to use the GeoWeb system for that sort of application. It fits easily with the ideas for how you would think about slope protection. For GeoWeb walls, it might be brand new. So let's talk a little bit about some of the benefits of using a GeoWeb earth retention system. Things like aesthetics, I've mentioned a number of times, but one of them is that it does have a low carbon footprint. So these are aesthetically pleasing and environmentally friendly. And that's due to their no maintenance vegetation and their ability to capture that stormwater runoff. As I said, using local vegetation is going to ensure that easy growth and that good environmental application for it. And then the installation of the GeoWeb systems is going to be fast and quite easy. The material is very lightweight. You don't need heavy machinery to install these type of things. Like if you think about masonry block walls, you usually need to vibrate those down into place, or gabion basket walls, you need heavy cranes to lift those large heavy baskets in place. None of that's necessary with the GeoWeb system. So you can try and reduce your impact in terms of the installation that you're doing. And then they also have great tolerance for soft soil environments. That's probably one of the best benefits to using the GeoWeb system in general, is that it does have that ability to tolerate differential settlements because the panels themselves are quite flexible. So by building over soft soil environments or areas where you know that you're going to have differential settlement, over landfills is a common place where you know you're going to get differential settlement. Using the GeoWeb system is a great way to mitigate the harm that comes from that differential settlement. The panels can flex and bend over that settlement as it occurs without damaging or destroying the structure as a whole. So a reasonable differential settlement is different for every project site. There's no, this is the line of what differential settlement is acceptable and not. But in general, GeoWeb walls can handle several inches of differential settlement, which can be vital, especially if you have maybe saturated soils that might see some areas full of saturation while others stay dry. You can definitely see where settlement could occur there. So that's a great application for that. You can see the photo here during installation, and then here's what it looks like after that installation is complete. Vegetation is starting to grow in. This is now a great way for this roadway to stay in place, and now you don't have to worry about that wall face eroding down, falling down onto that roadway and closing the roadway. So this slide, it's been, gosh, a number of years now, but we can all remember the very large earthquake and tsunami that hit Japan. The Fukushima disaster was obviously disaster. But so the GeoWeb walls have been proven to be able to resist tremendous earthquake forces and is one of the preferred solutions for dealing with those type of seismic issues. So this was a wall that was in place not directly in the path of that tsunami, luckily, but in the area that felt pretty significant seismic ramifications from that earthquake that happened. So you can see this was a wall that was put in place, and then it had a concrete flume down the center of it. You can see the before and the after. That concrete flume broken, destroyed, has to be replaced entirely. The GWeb walls themselves actually stayed in place and no maintenance was required once they had to go back and try and fix that flume. The walls were exactly where they needed to be and they didn't need to be fixed. So that's a great sort of testament to how well they can handle those types of really harsh conditions when those seismic forces do come through. So you can imagine how a rigid concrete MSE wall would have fared in this type of application. If that flume is completely broken as it is, a concrete wall probably would have been just as broken. So this is, a great application if you know you are in potentially seismically active areas. Durability is also a great aspect of using the GWeb system. So that, as I've mentioned a couple times, the panels are made of HDPE, that high density polyethylene, and it is resistant to chemicals, water, the freeze-thaw cycle, and it is not going to break down when exposed to sunlight. So a UV stabilizer is added so that you're not going to have the panels become brittle or crack or break down. You're not releasing plastic into the environment as it breaks down over time. It is very durable. It's chemically inert. It's not going to react to any sort of environmental conditions that it's in. So that's a great sort of aspect when you are talking to especially regulators, or if there's any sort of environmental concerns, you can say this is a long-lasting, stable, durable material that is not going to spall or crack or have any sort of degradation over time due to environmental concerns. It's not harmful or detrimental to our environment when it's put in place. So this was a project located in Iceland. I kind of just want to point it out because I think it's kind of a unique and cool project. And this was, it needed to be a wall to resist avalanches to protect this little village on a sound in Iceland. And so they built up a GWeb wall from nothing into this large avalanche protection wall. And so I think that's just kind of a really cool, unique application. Obviously not something the majority of us need to be concerned with, but there are definitely these types of really unique situations, and the GWeb system is a new and different solution that you might not think of, but actually work out really well for these types of things. And this is a photo immediately after installation, but over time it is actually going to grow in vegetation, become just sort of a large green retaining wall. You won't see the plastic. It will look, again, a little more natural, but again, you will still see a large wall there because walls are visible. But it's a kind of a cool application. And I don't know how many of us get to Northern Iceland, but if you ever are there, you can go see this, and it's a pretty cool little project. All right. Forgive the poor quality of these, but these are actually from the tests that we did with the U.S. Army Corps of Engineers. I believe these were in the early 1980s, but it was originally a solution for a problem that the military faced, which was quick deployment for crossing beach sands with heavy equipments, including tanks. And so you can imagine trying to drive a heavy tank over a beach. You're really going to not go very far. The tanks are just going to keep sort of digging down and rutting themselves into the beach. And so the extreme durability of the GWeb retaining walls has lent itself as this sort of military solution. In this case, this was Operations Desert Shield and Desert Storm, which required the U.S. Army to safely move and store large quantities of ammunitions. And so in this case, they were actually seeing expedient blast deflection systems and safe storage for those ammunitions during training and maintenance cycles. So again, not something every one of us has to deal with. Most of us do not have direct interactions with tanks and large ammunitions, but you can see the durability, the flexibility, the uniqueness of the GWeb system and how it can function for a lot of these different types of projects. And you can imagine, even if you have a project that is just really stymieing you, you don't know what your solution is going to be, this could be it. This could be the thing that gets there, because it is capable of doing a lot of really interesting things. All right, flexible design. I'm going to keep us moving here. So like I've mentioned a couple times, the GWeb panels themselves are very flexible, and so they can be used for a variety of different things, including going around corners. You can flex between different types of infill materials. In this case, they put concrete down in the lower tiers and then vegetation above that. And the concrete in this case was because they were going to have active water flow. This was a channel, stormwater diversion channel, actually. So it was moving water, at a pretty relatively high clip, moving around this corner. And that's, as anybody who does work with water on a regular basis can tell you, going around corners is where you have that highest potential for erosion in these types of applications, because you got that turbulent flow, you're moving from one direction to another. Definitely an area of concern. So the GeoWeb system can handle those high water flows, and you can put it in with topsoil if it's, low water flow, or if it's intermittent, there's not a lot of water there. But if you are going to have higher flows, if it's continuous water flow, put in concrete so that you have that good hard armor protection for the water flow, and then do vegetation above the high water line so that you have that green look still. So a lot of good flexibility in terms of physical flexing around corners, but also flexibility on project needs. Like I said, again, you can do that mix. In this case, this was another mix of concrete and vegetation, but it was good for urban use. So don't think that this has to be large industrial projects only. If you're working on residential projects, or you're trying to go just through, urban environments, building a channel behind a row of houses, this is a great application for that. And doing retaining walls can be a good thing if you do have that limited space. If you don't have a lot of footprint to be able to do a nice shallow channel that's maybe 20 feet wide, do a retaining wall where you have significantly steeper slopes, so you have a steep channel to be able to support all of the water and still be able to hold itself in place, but now you've got maybe a 5 foot wide channel. So lots of options there as well. In this case, they left the channel bottom as is. So this is a natural stone channel bottom, and then they built up retaining walls for the GeoWeb on the side. They did a little bit of concrete on the bottom and then vegetation above that. So again, that's where you have that flexibility. If the channel bottom itself is not stable, or if you do have concerns about erosion, if it's very sandy perhaps, and you're going to have water flow and you're concerned about that sand erosion, you can put the GeoWeb along the bottom of the channel as well. So you do have that flexibility of where the GeoWeb goes, what you fill it in with, and how much space you use it for. So again, lots of project specific questions or needs that we're more than happy to discuss with on a one-on-one basis. And some challenging site conditions. So again, this is where I talked a little bit about using it as a fascia. So rather than doing some excavation and building it up as a retaining wall, you're putting it up against a bedrock or otherwise like a rock face, something that is going to be there. This was an area where they were concerned about rockfall, and so they put the GeoWeb system as the fascia just in front of this rock face to help hold the rock face in place and grow a little bit of vegetation if possible. And so you can see this is a pretty challenging site condition, not something that everybody wants to be in on a daily basis, but it was a pretty interesting little project. They were able to build this up to help hold that rock face in place. And so in this particular case, the rockfall was only a concern on the bottom half of the wall. That is a question I will leave to the geologists to tell me whether or not that rockfall is in place or not. But you can build the wall up steeper and higher if you need to. So if you needed to cover this entire rock wall, you totally could. If your geologists are saying, hey, that top of the rock face is good to go, we're not concerned about any rock fall coming off that, but the bottom is getting really eroded, maybe you're concerned about impacts if there was a car accident or something, and that could destabilize the rock face. The GeoWeb wall is a great sort of barrier to that. So that's why they only did it on the bottom half. You totally can go all the way up to the top. Don't think that you have to stop halfway, but it's a great way to sort of mitigate some of those concerns on these really steep rock faces along roadways, and without having to do extensive blasting or excavation of that rock face or losing any space of your roadway. So this is a really small footprint of a site project, but a great way to still get that protection. All right, ease of construction is great. So if you do have existing structures, in this case, there was a large culvert that they needed to build around. We've had lots of contractors come back and say, I'd never used this before, but it was actually really easy to install. Again, you don't need heavy equipment to install any of this stuff. You don't have to lift it by crane or anything. Usually the biggest equipment is like you see here, an excavator, and that's to put the soil or the stone in place so that you don't have to do it all by hand. So very easy to install. You can go around and meet up with existing structures or put in other structures. In this case, they also decided to put in sonotubes through the GeoWeb wall, and that is for later construction of things like guardrail posts, or if you've got utility infrastructure that's got to go down through this area for whatever reason, putting in those sonotubes during the installation process is a great way to make sure you still have that access that you might need. And then landscape conformance, kind of already covered this because it's talking about the flexibility of it. You can go around curves, you can go up and down hills, that sort of thing. But it is nice to see that you can build your roadways all the way up to the very edge of the GeoWeb walls. You don't have to have, you know, a 5-foot or a 10-foot setback from the edge of the wall face before you can start having roads or buildings or anything. You can go right up against the edge. So again, if you have those smaller footprints you need to be concerned about. And you can put in those guardrail posts, again, if you had that utility infrastructure, anything like that. So this is a great way to see that. In this case, you can see that they filled in with concrete at the top couple of cells to be the foundation for their roadway. And then they actually did stone on the lower cells. They weren't interested in growing vegetation here, and that's totally fine. That's their aesthetic choice, no concerns on our end. But so it's, again, a great way to see that you have that flexibility of what infill materials you can choose. All right, so I need to talk a little bit faster, so here we go. Excuse me. Let's look at some case studies. Everybody likes seeing these things in the real world. So this was a project in Hawaii. This was a access road that was going to Wheeler Air Force Base. And so there were some landslides that had taken out the access road. And so they needed to repair and replace that road, obviously, as quickly as possible so that they wouldn't lose access to their base. And so while vegetation was plentiful on the island, the base had decided that they wanted to use a gravel pit that they had on site to provide the infill material. And so this way they didn't have to worry about installation, any material costs. They already had the aggregate on site. And so the area was cleared and excavated. They took out the washed out road sections. They removed all those damaged road sections and excavated past the extents of the washout. So they went out past where the failure had occurred and into competent soil slope. And so due to the height of this wall, they did include GeoGrid tieback reinforcement to help support that wall face. And in this case, the gravel infill was a great choice since drainage and water flow were really big concerns. Obviously, they had already had washout and erosion, so they needed to make sure that was minimized going forward. In this case, they used a relatively small stone size. It was a 3/4 inch to 2 inch minus stone. So it gave good compaction within the wall, but still let the water flow freely through the structure. So there was good drainage and minimal pore pressure buildup behind the wall. So you're not looking at using large riprap style boulders. You are looking at using a good, clean aggregate gradation. And it is important to limit the fines content of your aggregate when you have drainage concerns like this. And when I say limit, I'm thinking 10% or less fines in your material. And that way you don't have to worry about it clogging over time or potentially having that pore pressure buildup. But including other drainage, such as wall drainage, is a really beneficial thing to do as well. Let's see. So as you can see here, all of those panels are being stacked on top of each other. So you put in a lift, you fill it in with stone, and then you can put the next one on top of that. And then you do a little bit of compaction with each layer. You do want it to be with a roller compactor, not vibration. Vibration actually lifts GeoWeb panels up out of the ground, out of the stone or soil that it's put into. Might be a little counterintuitive, but rule of thumb, no vibration, roller compactors are going to be just fine. And really, you really just want that gravity weight compaction. You're not looking for excessive or over compacted stone, because again, you still want it to be open and drainable material. In this case, they did install some of those guardrail posts at the top, and then were able to pave the road on top of that as well. They also put in a large diameter drainage pipe. You can see that corrugated pipe coming out at the bottom of the picture. That was something that they put in for extra drainage behind the wall, because they knew they had drainage concerns, because this had been a washout area prior to installation. In this case, they didn't care about aesthetics, so they just left that large drainage pipe just sort of hanging out there. You can clean that up a little bit on your site if you don't want that just hanging out, but either way, drainage is pretty important. And now it can withstand some of those really punishing storms that Hawaii can get, and now it can carry all of the vehicle traffic that that Air Force Base needs on this new road. So great application there. This was another gravel infill. This was actually over in Japan again. And so you can see it has some really nice vertical alignment of those cells. You can see how nicely they're all stacked on top of each other. Or you can do a batter check boards, and that helps you make sure that your batter is in place. So these are just sort of installation-y type pictures to help see what it looks like as it's going in. You can follow all of these rules. You can be a little bit more freehand if you want. But again, if you do have installation questions, we have both installation guides and videos available on our website that you can watch or download, or we are more than happy to talk through those with you one-on-one. And we offer site installation support. So when you've got your recommendation and you bought all materials and you're out on site and you're like, okay, we're ready to get started, but we've never done this before, how do you help us? We can have a representative from Presto Geosystems on your site to help train and make sure that everybody is comfortable putting this type of system in the ground. So even new contractors or people who've never done this type of installation know what they're doing and feel comfortable that they're getting the right solution. And so that's just something you reach out to us, say, hey, we're getting started on, you know, the first Monday of the month. Can somebody be out here? And we say, yep, sure, somebody will be there. They'll make sure everybody's good to go. So installation support, definitely something we offer. Feel free to reach out to us. Some other nice photos, again, installation style. You can see those batter check boards on the right-hand side. That just helps make sure that you have the right setback of all of those panels. And that's going to make sure that you get that good face angle. I know there was a question at one point in the Q&A session was, how far of a setback do you need between the individual panels? And if you're doing tiers, is there a minimum setback? And so there's a lot of flexibility in how much setback you have. And typically the steepest that we offer is an 81-degree batter face, so not perfectly vertical. It means you have approximately a 1-inch setback between panels. So as each layer goes up, this sets back about an inch. You can go a steep or a longer setback for a shallower face angle. And then if you do have tiers, there's no minimum separation between tiers. Typically we see between 5 and 10 feet, but it can be a little shorter, it can be a little longer. Again, it depends on your space constraints as to what that separation between tiers is. So I just know I saw that in the Q&A and people have questions about that, but we can talk about that more if people have more questions at the end. All right, so next case study, this one was a vegetated infill. This was a gully down in Lem Gully, Texas. And so you can see that this was going to be an area of continuous flow, and you can see it's pretty clayey soil, and they already had this pipeline in place with foundations. And so the idea was that they needed to protect these foundations from erosion from water flow through this gully. So in this case, they did block off all water flow through the gully because they wanted to work in dry conditions. You can work in the wet with the GeoWeb system as long as your contractors are comfortable with that. That's absolutely just an installation comfortability thing, dry or wet. So don't think it has to be dry if you're not capable of doing dewatering for your site. So in this case, the area again was excavated to allow for that installation of the panels, including the area behind the panels to allow for additional drainage infrastructure. And in this case, they did put a geotextile over that natural slope because it was so clayey. And so they wanted to help have that separation between that clayey soil and the stone and vegetation infill that they were going to place. So you can see again the layers going in here, and this is actually a pretty good picture to show if you are going to do a topsoil and vegetation wall, you want that vegetated green wall, you only put the topsoil in that front cell, so in the very outer face of the system where it's sort of the darker brown here, that's going to be topsoil, and then the lighter gray is actually all stone, it's all aggregate. And so that aggregate allows for the water to flow through. It's nice and vegetated. It gives a little bit of a stronger structure because that stone can lock up against itself, whereas soil is naturally not as strong as stone. So it's definitely something to talk about. We'd be more than happy to discuss what your infill requirements are. It is again going to depend on what you want your face to be, whether it's vegetated or stone, and what your drainage capacity is on your site. And then you can also see he's got a sort of wooden board that the guy in orange is working with. That board is just holding open the cells of the GeoWeb panel during the installation process. So it just makes sure everything is held open and in place as you fill in with soil or stone. And then you lift up that wooden board and you move on. That's not a permanent part of the structure. It's just an installation guide. All right, and then so you can see the walls were built up on both sides of this gully around that existing pipe foundations. And so it's great to see how flexible it can be as it goes for that sort of easy contoured look throughout the gully. It really works with what's there. And then the GeoWeb panel can withstand the anticipated water flow with no concerns about erosion or undermining. And so we do have research and testing showing how the GeoWeb system works during hydraulic situations, hydraulic flows. So, and that includes topsoil, stone, and concrete. So if you are in a water flow situation or you're concerned about how the GeoWeb system is going to handle that water flow, we have it on our website, or we're more than happy to give it to you directly and talk about what it means, what the details are, that sort of thing. So feel free to reach out to us about that type of research and testing. We're not going to necessarily talk about it anymore today. And then here's what it is as it's starting to fill in. So you can see that the grass along the bottom filled in first, but it's going to start coming up on those slope faces as well, so that you don't see the plastic. You're just going to see nice green slopes. And then this is going to be a great vegetated aggregate mix. So this was again somewhere where they were going to have water flow. So they were concerned about erosion of the side slopes. And because there was going to be continuous water flow through the area, they knew vegetation wasn't going to grow along the bottom of this channel. So they put it in with stone so that it would be nice and stable. And then above the high water line, they put in vegetation. And you can see they've got pipes coming in directly through the wall face. So again, good flexibility of the GeoWeb system to be able to go around existing structures or additional built-in structures. And then here you can see once all that vegetation is in and the water is in place, you don't see any of the plastic material, but it is now a good, stable, strong structure. So it's not going to wash out the road to the left or encroach on people's homes to the right. This was another mix of topsoil and stone. This was actually in Tokyo Bay. So they knew they were going to have some pretty intense both wind and potential water flow over this area because it is in this coastal environment. So another great application of the GeoWeb system here. And then the last infill type that you can do is concrete. It's not super common to do concrete walls just because it is not the most aesthetically pleasing and is sort of defeating what you can do with the GeoWeb system in terms of vegetation or stone. A lot of times you could have done this just as well with a modular block wall sort of thing. But you totally can do concrete if that is what you are concerned with and what you're looking for on site. If you have very high water flows, concrete is a good option. You're not going to get any erosion with concrete, obviously. So something to consider is if you know that you are in those high water flow situations, this is a great option for that. And this is another concrete wall. Again, we've done a lot of walls over in Japan. This is something that their infrastructure really focuses on and does a lot of work with. So that's why a lot of our photos are from there, but they do also some really great installations. Photos look great. So this was along an expressway and where they knew they were going to have water flow. There were some culverts that they went through. So they did all concrete in this area so they wouldn't have to have any maintenance, and they knew that it would be able to support all of their vehicle traffic. And it's extra resilient when it is concrete. You know that you don't have any concerns on impacts. If there were to be anything in the water that might potentially impact the walls, concrete is going to be able to withstand all of that, all of your heaviest vehicle traffic, all of that good stuff. Drainage concerns, I've mentioned them a couple times, but I really just do want to highlight how important it is to focus on your drainage concerns, because if you do have poor pressure buildup behind your wall, that is the leading cause of retaining wall failure. And again, you can see those wooden boards, those are holding open the GeoWeb walls, the GeoWeb panels, and those are just a temporary installation measure. And you can also see the GeoGrid tiebacks in this case. They're putting down a non-woven geotextile for separation, and then those GeoGrid tiebacks for the internal reinforcement. And in this case, they are putting a perforated pipe along the back of the GeoWeb panels for drainage collection and to prevent that poor pressure buildup. So you can see that right there with that guy. And then they were daylighting that pipe through the front of the face so that they knew where the water would be coming out. You can have it daylight through the front of the face. You can have it come through the side if you're near the edge of where the GeoWeb walls are going to be. Lots of options there. You really just want to make sure you know, if you are collecting that water, where it's going to come out and what it's going to do in terms of water flow, if you need to collect it, anything like that. And then the last project that I do kind of just want to highlight is a special case where you use the GeoWeb system as a freestanding structure where it's not bounded by existing slopes or other earthen embankments. So this was a special job done down in the port of Tampa in Florida, and they needed large earthen mounds to be built up underneath their liquid natural gas tanks as work platforms. And so obviously the mounds were going to be completely new after they had installed the tanks and their foundations. And so this was a great way for the GeoWeb system to be built up independently of anything else, back to back against itself, to create this basically earthen levee underneath these platforms. And so the LNG tanks and foundations were built, and then the GeoWeb wall was built up around them. So you can see they put all of the soil in the middle and then started doing the GeoWeb installation in front of that. And so it's a great way for it to go all the way around the perimeter, including around those tight corners, and be fully connected to one another. So it is a fully connected, cohesive system, and it is supporting itself rather than relying on anything else to be the support for the system. And again, you can sort of build it up however you need. You can do all one side, you can kind of go around stacking it up like Lego bricks, however you need for your installation. So you can consider your live loads, your dead loads, all of those good things for what you're doing on site. And again, this is where it'd be great to have one of our representatives on site for that installation support and assistance. Just make sure everybody is comfortable with how this is going in place. And then this is what that looks like. So definitely a unique application. It's not what people would normally think of when you think of retaining wall, but it's a great way to support these types of large infrastructure applications and get the type of working platform that you need. Okay, and then the last thing I want to point out is that we do have a free software. It's available on our website. It's called GeoWeb MSE, and it is something that you can use to help determine if the GeoWeb system is going to be appropriate for your project. So it's on our website at prestogeo.com. And so you just come up here to the design tab, and then you fill out a request license tab here. It's just a really short form saying, hey, I'm looking for this. Send me a license for it. You get a password for it. It is completely free. You don't pay for it, and we do update it once a year. at the start of the year to make sure that it is up to date with all FHWA standards and anything else that might have come out over the course of the year to make sure that it is going to be the most accurate that we can give you. And so it just helps you determine what is going to be appropriate, if the GeoWeb system is going to work for you, what type of reinforcement you might need, how much excavation might be required, that sort of thing. We're not going to get into any more details today, but we do have a webinar devoted specifically to this software coming up in March, I believe. So keep an eye out for invitations to that if you are curious about using this software. Okay, and I've gone over my time, so I appreciate anybody that has stayed with me, but we've covered GeoWeb retaining walls today, also steep slopes, so lots of good benefits, including being able to have vegetated faces, go into projects or challenging project conditions, including differential settlements, seismic forces, hydraulic forces, all that good stuff. And we have that free software that you can use to determine how the GeoWeb system might work for you. So again, we have our website, prestogeo.com. You can fill out a free project evaluation request, and that's where it comes to myself and the rest of the engineering team to determine if we need to, or what type of application is going to be right. All those little, what size, what depth, what length, what type of reinforcement, all those little nitpicky things that we covered, where the no one right size fits all, we help you determine what is going to be most appropriate. So you fill out the form with what you have. You can attach documents if you've got plan sets or geotechnical reports, anything like that. And then we give you a CAD detail. We give you supporting calculations, documentation, including specifications, everything you need to throw into your bid documents, give to your regulators, all that good stuff. And again, specifications, make sure that you are using materials that you can trust. We have over 40 years of expertise. All of our materials meet or exceed our specs, so you can build with these. No disclaimers, no concerning fine print, all that good stuff. A little bit of housekeeping, webinar, PDH credits. If you listen to me live today, as I run through this, you do get a PDH certificate. It is coming from GoToWebinar. You'll get that by the end of today. If you are listening to this recorded, it will come from Presto Geosystems. So this webinar was recorded. It's going to go online to your webinar dashboard. If this is not your first Presto Geosystems webinar, you know all about the dashboard. If you are new to us, you will get an email by the end of the week telling you how to get on this webinar dashboard. You can review this webinar, you can review past webinars that we've done, you can earn PDH credits by watching other webinars on demand, all that good stuff. So 2 potential emails, GoToWebinar and Presto Geosystems. And as always, feel free to check your spam folders if you aren't seeing anything, but reach out and we are more than happy to give you assistance if you need it. And finally, here is my contact information. Again, feel free to reach out to me if you've got specific projects, if you're just looking for a general overview, if you just want to chat about anything we talked about today or anything we didn't talk about today. I am more than happy to discuss this with you. I'm a good technical resource and I can direct you to people in terms of pricing and all of that stuff. So I'm a good first step if you do have any questions. So thank you everybody who has listened to me today. I apologize for going over. If you're interested, I am going to stay on for a couple extra minutes and do a couple of these questions that came in. Lots of good questions came in. The Q&A is being recorded, so if you have to go, you can watch that on the webinar dashboard in a week. If not, thank you so much, and we hope to see you at future webinars. Whew. Okay, went through that last little bit really fast. I appreciate everybody that has stayed with me, and I apologize for not managing my time super well. But let's get to some of these questions because there were some good ones. So lots of questions about the type of reinforcement. I mentioned most of the time we recommend GeoGrid reinforcement. It's not the only one. It's just what we see a lot. It's pretty common. Again, it does follow those FHWA standards to use GeoGrid reinforcements, but really you just need something in those really tall wall situations to help support the entire face and retained area of your wall. So if you are concerned that you have deep-seated failure, if there's going to be a circular failure that happens, anything like that, you've got to be able to cover all of that area that is the reinforcement concern. So typically we will recommend some type of, geosynthetic reinforcement. Geogrids are the most common because they're pretty easy to do. You can also do geotextiles. Woven geotextiles are probably the most common because those have a little bit of strength to them, whereas non-wovens, not super strong. But so you can lay out geotextiles in that retained area, same as you would a geogrid. You can also do anchors. Especially if you're against a rock face, you could do rock anchors into there. You can do soil nails into a soil face. So there's lots of different options for what type of reinforcement you have. And I know I said geogrid a lot, but I don't want you to think that that's the only option. So there's a number of different reinforcement techniques that you could do. And that's something that the software can help you determine, and something we can help you determine if you have questions. So if you have a limited footprint and you're concerned that you won't have enough space for a tieback, we can help you determine, what type of rock anchors might be the most appropriate, that sort of thing. So lots of different options with reinforcement techniques. I do urge you to read things like the FHWA manual for retaining wall designs. The U.S. Army Corps of Engineers has a number of good manuals because we do follow those standards. We haven't reinvented the wheel with that. So that's going to give you a really good fundamental understanding of how and why that reinforcement needs to happen. Okay. Some questions about how steep the walls can be and what's the face angle, that sort of thing. So yeah, so there's a number of factors with that. You can't go perfectly vertical. We can't get to 90 degrees. We can get to 81 is our maximum. And that gives you that 1 inch setback between each layer of GeoWeb panels. That's what you saw in all those pictures, that 1 inch setback. So that's the steepest you can go. Honestly, that's sufficient for most projects. For some reason do require vertical. You might need to go to something like a H-pile wall. That's vertical is hard to get to, I'll say. 81 degrees, 80 degrees is pretty common in the MSE retaining wall world. But you can go much shallower than that. Like I said, we've gone all the way down to a 1-to-1, so a 45-degree wall. That gives you a really far setback between each of those panels, each layer of panels. Good for growing vegetation. Still takes up a lot of space, so it's not really saving you in footprints if you do it like that. So that's sort of some of the things you might want to think about as to what your face angle is. If you're doing the excavation, that gives you a lot of flexibility on what your angle is because you can choose. If you're doing a fascia, so if you're going up against like that rock face, we saw a couple pictures of those, that gives you a lot less flexibility. You're sort of confined to what the rock allows. I would say pretty much anywhere between 81 degrees and 45 degrees for that face angle. So hopefully that helps. Let's see, I'll do questions about water flow. Yeah, so lots of questions about either putting it in a channel or being up against somewhere that might see wave action, like an ebb and a flow, or even significant actual wave action if you're in a coastal environment. So yeah, the GeoWeb panels are rated for and intended for water flow. Like I said, we do have research to back that up, and I'm more than happy to share that with anybody that's interested in it. But you can have intermittent or continuous water flow in a channel environment, so where it's flowing in a certain direction, and even including corners. We saw a couple pictures of it going around turns. And so it can handle the flow along channels. It can handle the turbulence of corners or variations of your channel. If you've got turns or dips or anything where it might be a little bit of a turbulent water flow, the GeoWeb panel can handle that. Around 20 feet per second flow is sort of the maximum unless you go with concrete. If you have concrete, you can have whatever kind of water flow you want. Concrete's not going to erode from water. But in terms of topsoil, around 20 feet per second is where you're looking at for a maximum flow. If you're in maybe a lake environment, lake, small pond, maybe a dam embankment where you have like ebb and flow of water or rise and fall of water levels, the GeoWeb panels can handle that as well. The flow, the ebb and flow can hit the wall face and go back. The water level can rise or fall, and all of the material is confined within the cells of the panels, so they're not getting washed away or moved around. They're not going to get sort of pulled down and out of the system. It is a properly installed GeoWeb wall is founded so that you don't have undermining concerns, things like that. If you do have significant wave action, if you are in, say, a coastal environment where you have actual waves and not just the ebb and flow, but like pounding waves, we would encourage you to think about doing concrete, just because that is going to give you the most amount of protection. But again, the GeoWeb panels and the system itself is capable of handling that. It's not going to break or degrade or fail due to wave action. And if you do that concrete, you know you're going to have good protection. You're not going to lose any material because of that. It's not going to become damaged due to wave action. We have done a number of applications in all of those environments: channels, lakes or ponds, and coastal. We even have a coastal erosion webinar on the webinar dashboard. If you have access to that, feel free to go back into the library and look at that webinar. But we've done a number of projects for all of those different conditions, so we have experience, and we're more than happy to talk to you or to regulators about that as well. I am going to call it here in terms of the Q&A, but I would be more than happy if you call me, email me, anything like that. I would be more than happy to talk more about any questions that you have specifically. I will reach out to you as well if you submitted a question, and try and get those answers back to you as well. I hope you all have a wonderful day. Thank you for staying with me, and I hope to see you at future webinars. So have a wonderful rest of your day, and bye.